Look at the thick steam escaping from that webbed crumb. Achieving this exact texture, impossibly light yet perfectly structured, is the baker's ultimate goal. To get there, you only need 4 ingredients: flour, water, salt, and yeast. Yet despite that total simplicity, creating a perfect loaf remains one of the most difficult culinary skills to master. That difficulty exists because baking bread means managing a living biological timeline. The dough is alive, and coaxing it to perfection requires a constant negotiation between precise chemistry and human intuition. Watch Chef Kwame at work in his modern Pan-African bakery. He has to operate with a dual mind. In one moment, he acts as a scientist running strict analytics, and in the next, an artist relying entirely on tactile sensory feedback. He is managing a 12-step domino effect. Because these steps are sequential and interdependent, a microscopic miscalculation in step 1 will invisibly, but inevitably, sabotage step 11. The first step is scaling, and it requires absolute mathematical precision. Measuring by volume, like using cups, introduces wide margins of error. Bakers use digital scales and baker's percentages to control exact hydration levels down to the gram. Step 2 is mixing. This is a deliberate mechanical process used to build a molecular framework. The friction of kneading stretches the proteins in the flour, aligning them to build strength. This animated diagram shows exactly what is happening at the microscopic level. During an optional resting phase called the autolyse, where only flour and water sit together before yeast and salt are added, the gliadin and glutenin proteins physically cross-link. They hydrate and bond naturally to form a strong, elastic, web-like network known as gluten. This microscopic architectural web serves as the foundation of the entire loaf. Its precise structure dictates the dough's future capacity to stretch and trap expanding gas without tearing. Once the structure is built, you reach step 3, bulk fermentation. This is the longest phase, where the biology takes over. The yeast consumes sugars in the dough and exhales carbon dioxide, along with organic acids like lactic and acetic acid. This is the exact moment the bread's complex flavor is born. Step 4 is folding, occurring right in the middle of fermentation. Here, the baker relies on tactile intuition. They feel the dough's strength and gently fold it to expel excess carbon dioxide. If they fail to degas the dough, the yeast will suffocate in its own waste. Steps 5 and 6 are dividing and pre-shaping. The baker cuts the chaotic mass into portions of equal weight and rounds them. This organizes the dough and establishes a permanent structural axis, a smooth top, and a seam side on the bottom. Before proceeding, the dough requires step 7, the bench rest. The newly formed gluten matrix is highly tense from the pre-shaping. If the baker doesn't let it relax for 10 to 30 minutes, the surface will violently tear during the next phase. Step 8 is final shaping. The baker uses their hands to pull the dough tight, creating surface tension across the smooth side of the loaf. Whether forming a round boule or a long baguette, this deliberate tension forces the bread to expand upward in the oven, rather than flattening outward. Step 9 is final proofing. This last rise is highly volatile. The dough must hit a precise threshold of 85 to 90% of its maximum volume. If it proves too long, the structure weakens and collapses. If it doesn't proof long enough, the tight surface will rupture entirely in the heat. By this point, the baker has transformed raw chemical potential into a delicate, highly pressurized living structure, balancing perfectly on a razor's edge. Step 10 is scoring. The baker takes a razor blade and slashes the top of the proofed loaf. While often viewed as an artistic signature, this cut acts as an essential engineering pressure release valve, dictating exactly where and how the dough will handle its explosive expansion. Step 11 is baking. As the dough enters a 460-degree oven, we get what's called oven spring. The baker injects steam to keep the crust pliable, allowing the trapped gases to rapidly expand. Looking at this cross-section of the loaf, you can see the internal temperature climbing. Once it hits 140 degrees Fahrenheit, the yeast activity abruptly dies off, and gas expansion hits its absolute peak. The heat continues to penetrate. As the internal temperature reaches 167 degrees, the proteins in the dough coagulate. The stretchy, expanding gluten web visually locks into a rigid, permanent structure. Meanwhile, the surface temperature of the crust exceeds 212 degrees. This triggers the Maillard reaction and caramelization, rapidly transitioning the outer perimeter of the loaf from pale dough to a rich, dark, textured brown. Once the loaf is pulled from the oven, we reach the 12th and final step, cooling. It is incredibly tempting to slice into a steaming hot loaf of bread immediately, but doing so will ruin the texture. The chemistry inside the loaf is still actively changing. A process called starch retrogradation begins immediately, drawing moisture away from the crumb so it can fully set. At the same time, the organic acids developed during fermentation require hours to settle and stabilize their flavors. Mastering extreme heat in the oven and then practicing strict patience during cooling is the only way to lock in the invisible labor of the preceding 11 steps. After the bread has cooled completely, the baker can finally make that first slice. The knife cleanly breaks through the dark, crisp crust to reveal a perfectly structured, airy crumb inside. To achieve this result, the baker had to act simultaneously as a structural architect, as a microbiologist, and a tactile sculptor. A truly great slice of bread is the edible culmination of 12 flawless, interconnected decisions.